Ever wonder if a scientist's early success sort of predicts their whole career? Like, if they start strong, do they stay strong? Or can someone who starts slower, catch up later on?
Just a great question.
We've really dug into this fascinating study that tracked a massive group of scientists, late career ones, over decades to see if those early patterns hold up.
Yeah, this is a really significant piece of research. We're talking longitudinal analysis, over 320,000 scientists who were well into their careers, tracked across 38 different OECD countries.
Wow.
And it covers a huge range of fields. Your STEM disciplines, physics, medicine, biology,
Yep.
but also social sciences like economics, psychology. It's broad.
And the data source is key here, right?
You're-
Scopus.
Exactly, Scopus, this massive global bibliometric database. It lets you track individual publication histories over, well, really long time, 25, even 50 years for some of these individuals.
Right. So our mission in this deep dive is to unpack what that data tells us about the dynamics of scientific productivity. Are there clear patterns? Do people stick where they start, high or low? And how often do those really dramatic shifts actually happen? The kind of underdog stories or maybe fading stars.
Yeah, looking for those persistent performers and also the outliers.
And it's not just counting papers, is it? They used a specific method.
No, and that's important. They used a journal prestige normalized method. So it counts for the quality, or let's say the selectivity of the journals where the work is published.
Okay, so quality matters.
It tries to get at that, yeah. Using journal rankings from Scopus.
Yeah.
And they look at productivity across 3 career stages,
Mm-hmm.
early, mid, and late.
Gotcha. Okay, so let's dive in. You mentioned one key finding that was maybe a bit surprising.
Well, yeah, considering how dynamic science feels, right? Always changing.
Yeah.
But the study found remarkable stickiness, I guess you could call it.
Stickiness.
Yeah, in productivity levels for many scientists. Like once you establish a certain level of output, you tend to stay roughly in that zone.
Interesting. So the top performers stay top performers.
Largely, yes. The study calls this horizontal mobility, which sounds technical, but it just means people tend to stay in their lane, productivity-wise.
Okay.
So for those top performers, the ones in the top 10% early in their careers, over half of them, 52.39% to be exact, were still in that top 10% in their mid-career.
Wow, over half. That's significant persistence.
It really is.
But what about the other end? People who maybe struggled initially. Does that stick too?
It seems to, yeah. Maybe not quite as strongly, but still notably. They found that over about 37% of scientists in the bottom 10% early on were still in that bottom decile come mid-career.
So high or low, there's a tendency to kind of stay put.
That's a major takeaway from this data, yes. That initial productivity level seems to set a strong trajectory for many.
Okay, this is where I get really curious. We hear anecdotes, right? The late bloomer, the person who burns out. But how common are those big shifts according to this study?
Right, the study specifically looked for those. They call them jumpers up, bottom 10% early career to top 10% mid-career, and droppers down, the opposite journey.
Okay, jumpers and droppers. And are there many?
Well, this is maybe the most striking finding. They are incredibly rare.
Define rare. Give us the numbers.
Okay, so between early and mid-career, out of over 32,000 scientists they could track this way, only 162 individuals made that leap from bottom to top. That's about 0.5%, 0.51%.
0.5%? Wow.
Yeah, and even fewer dropped down. Only 82 scientists, which is just 0.26%, went from the top decile all the way to the bottom.
That's tiny. It really counters the narrative you sometimes imagine, doesn't it?
It does. It suggests those dramatic turnarounds or falls from grace, at least in terms of publication productivity, are much less common than maybe we'd assume.
And does this stability hold up later in the career, too, between mid and late stages?
Pretty much, yes.
Yeah.
Similar patterns. The numbers shift slightly, a few more jumpers up later on, about 1.36%, and droppers down were still very rare at just under 0.7%.
So the overall picture is one of, well, consistency.
A surprising amount of consistency over very long timescales, yeah.
Okay, but science isn't monolithic. Does this pattern look the same across different fields? I mean, is physics the same as medicine or economics?
Good question. And no, there are definitely variations, even though the overall trend of, let's call it immobility, holds.
Ah, okay. So where do we see differences?
Well, for instance, in math-heavy fields, the study looks specifically at math and PHYS, mathematics and physics, that persistence at the top end was particularly strong. High performers really tended to stay high performers throughout.
Okay, that kind of makes intuitive sense, maybe a cumulative advantage.
Could be. But then you look at fields like chemistry, COGEM, and computer science, COMP. They found very, very low chances of anyone jumping from the bottom to the top between early and mid-career, like 0.07% in chemistry, 0.13% in computer science. Tiny.
Even lower than the average.
Much lower. But then physics, interestingly, had a higher rate of jumpers up than those two, around 0.75%. So there are nuances depending on the discipline's dynamics.
Fascinating. And what about the social sciences? They often have different publication norms.
You might expect bigger differences, but the study found they generally followed similar patterns to the STEM fields. Persistence was high, radical shifts were rare.
Really? Across the board?
Yeah, which suggests maybe some core academic career structures or pressures might operate similarly across disciplines more than we think. Oh, and in medicine, MED, it was pretty average. Over 50% of top early performers stayed top, fitting right in with the overall STEM picture.
Okay, we can't really have this discussion without touching on demographics. The study looked at gender, right? What did the findings suggest there? And just to be clear, we're reporting the study's findings here.
Absolutely. The study performed regression analysis to see if gender correlated with the probability of being in certain productivity groups. For mid-career scientists, it found that being male increased the likelihood of being in the top 10% in 13 out of the 16 disciplines studied.
Increased it by how much?
It varied a lot. In some fields like computer science, math, economics, it was a smaller effect, maybe a 3–7% increase in probability. But in others, like immunology or neuroscience, the calculated increase was over 100%.
Over 100%? Wow, that's a huge difference in probability.
It's a very large calculated effect in those specific fields at that career stage, yes.
And did that pattern change later in the career?
It did shift somewhat. For late career scientists, gender was still a statistically significant factor in 10 disciplines, but the effect size was generally smaller.
Smaller how?
Increases in odds for males being in the top 10% were more in the range of 3–14% for fields like agriculture, earth sciences, material science, though still higher in neuroscience, biology, immunology, around 46–70%.
Still substantial in some areas.
Yes. And interestingly, math was an exception in the late career stage. Being male was actually associated with slightly decreased odds of being in the top 10%.
That is interesting. An outlier there. What about the bottom 10%? Did gender predict being in the lowest productivity group?
Much less so, according to the analysis. Being female was found to increase the odds of being in the bottom 10% only in agriculture and engineering in the first career transition, and then slightly in medicine in the second transition.
Yeah.
In most other cases, it wasn't statistically significant.
Okay.
And there were some contrasting field specifics too, like in biology, being male was linked to decreased odds of high productivity at mid-career, whereas in engineering, it was linked to increased odds. So it's complex.
Definitely complex, and lots to unpack there about potential underlying causes, which are beyond this particular study. So stepping back, what are the big implications here? For universities, for funding bodies?
Well, I think the main thing is it really emphasizes the potential long shadow cast by early career stages. If productivity tends to be this sticky,
Right.
then the support, resources, and opportunities scientists get early on could have really long-lasting effects on their output trajectory. It suggests that institutional decisions, hiring, promotion, early funding, might be setting paths that are quite hard to change later.
So getting it right early matters a lot, potentially.
That seems to be a key implication for institutional strategy, yes. Investing in early career high performers might yield sustained high output based on these trends.
But we should also talk about the limitations. No study is perfect, especially one this big. What caveats do we need to keep in mind?
Absolutely crucial. First, it's all based on Scopus index publications. That means things like teaching, mentoring, outreach, even some types of books or patents might not be fully captured. It's a specific slice of academic output.
Okay, so it's about publishing productivity, mainly.
Exactly. Second, it focuses on the survivor scientists who stayed active in publishing for at least 25 years. It doesn't tell us about people who left academia earlier for whatever reason.
Right, that's potentially a different group.
Definitely. And then there were methodological points. They had to infer gender, sometimes based on names using algorithms, which isn't perfect. They used first publication date as a proxy for career start.
Understandable for a study this size, but still proxies.
Right. And the main productivity metric relies heavily on journal prestige ranks, not necessarily the long-term citation impact of individual papers, although journal rank is obviously related to citation potential.
Got it. So, useful context to keep in mind.
Always.
Okay, so to wrap this up for you, our listeners, The big takeaway seems to be that the landscape of scientific productivity, or at least publication output, looks surprisingly stable over these long careers.
Yeah, that stickiness is really the headline finding.
That early success or lack thereof seems to set a course that, for most people, tends to persist.
That's what the data strongly suggests. Those really dramatic jumps up or drops down the productivity ladder. They happen, but they seem to be the exception, not the rule.
Which leaves us with a final thought to chew on. Given this general stability, what are the hidden factors? What allows that small percentage of scientists to actually make those huge leaps? Or, conversely, what contributes to the rare falls?
Exactly. Is it mentorship? Funding changes? A shift in research focus? Institutional support? Or lack thereof?
It really makes you think, doesn't it? About how we spot potential, how we nurture talent, and maybe how rigid or flexible the systems supporting scientific careers actually are. Something to consider next time you hear about a scientist's career trajectory.